In question number 11, again, this was a familiar one. We had a 38-gram penny on a turntable 12.6 centimeters from the center. If the coefficient of friction is 0.235, how fast must the turntable be spinning before the penny flies off? Well, the penny will fly off once the centripetal force it needs is bigger than the friction that's being provided there. So basically, it's gonna fly off right after the FC equals the FF. Well, I know FC is equal to mv squared over r, and I know FF is equal to mu mg. My m's cancel out. If I'm looking for v, the r is going to come up on this side, and to get rid of that, I'm going to have to square root that, which means after purification, v equals the square root of rug. So v is just going to be the square root of, and the r. The r is, again, how far away am I from the center? Here I was 12.6 centimeters away, but I don't want it in centimeters, I want it in meters, so that's going to be 0.126 meters. So we have to convert here. Then we have mu, and mu was given as the coefficient of friction is mu, so that's 0.235, and then g, of course, is 9.81. Now, if you're doing this in your calculator and you're sticking in parentheses, make sure everything is in one parentheses, or it will only take the square root of the first parentheses. So you may have to make it look like that. So anyway, once you get that plugged into your calculator, and after rounding to 3 sig figs, we end up with 0.539 meters per second. A couple of you will say, but wait, one of the numbers there only had 2 sig figs. Yeah, it was the mass, but the mass canceled out. We never used it in the calculation, so we're going to round to 3 sig figs.